Today we're going to look at some complex numbers. So if you remember, the complex number has a real and imaginary part. So in this case, the real part is 3, and the imaginary part is the 2i, or the 2. And so in the complex plane, the horizontal is the real, as we can see here, and the vertical axis is the imaginary. So if we needed to graph this point 3 plus 2i, we'd go over 3 and up 2i. So if we were to label the coordinates of this complex, like just in rectangular, it would be 3 and 2. So if we wanted to switch this into polar coordinates, so again, polar coordinates, we have to find our radius. So we know that this is up 3 and up 2. So our r, we would say 3 squared plus 2 squared equals r squared. So r squared equals 9 plus 4 is 13. So r is the square root of 13. And then again, we do the inverse tangent. And this isn't a unit circle value, so you could use a calculator on it. So if I go tan inverse 2 divided by 3, 0.588, and that works because it's in this quadrant. And again, it was in radians, so I'm going to just make sure to label I have it in radians. So this is the square root of 13 and 0.588. So let's take a look at this. A complex number can be represented by using the point 4 pi over 6 in the polar coordinates. So again, this is polar, so it's saying that, so this is our radius, and this is our angle. Graph the point on the complex plane above. So 4 and 5 pi over 6. So 5 pi over 6 is 5 times 30, so 150. And 1, we got to walk out 4. 1, 2, 3, 4. What is the real component? So again, this is 4. And if it's 5 pi over 6, I know this is 30. So we have our x and our y. So the real component is the x. So I'm going to say that the cosine of 30 is x over 4. So this is 4 times the cosine of 30. And let's see, so what are these values? 30 is, let's see, so this is half. This would be negative root 3 over 2. So we have 4 times negative root 3 over 2. So that's negative 2 over root 3 is our x component. And the imaginary component is our y. So I could say that the sine of 30 is y over 4. So 4 times the sine of 30 equals y. So that's 4 times half, so that's 2. So in Cartesian form, or rectangular here, so this would be negative 2 root 3 plus 2i. So just like the size and magnitude of a number is its absolute value from distance, the magnitude of a complex number is the distance from the origin. So if you wanted to find the magnitude, 1 minus 4i, we'd just do the Pythagorean theorem. So 1 squared plus negative 4 squared equals that magnitude squared. I'm going to call it r, so that's 17 equals r squared, so the square root of 17. So converting into a complex is much like what we did yesterday, using those same ideas of trig. So today what we're going to be talking about are notes here. We're going to summarize complex numbers and polar form. So just to review, this is our real axis and this is our imaginary. And complex numbers are of the form a plus bi. And so to put this into polar form, it is r times the cosine of theta, is that x, the real part, plus I, our radius, times the sine of theta for our y part. And oftentimes you'll see it factored out as r, the cosine of theta, plus I, the sine of theta. Okay, so let's take a look at some examples here. If we need to go from polar to rectangular. And we'll take a look at one in degrees first. So let's say we have 6. Let's say 6 the square root of 3 times the cosine of 240 plus I the sine of 240. So this is in polar, so I know our angle is 240. So I know that's not where 240 is, here. So I'm going to put, I know my reference angle is 60. And I know the radius is 6 square root of 3. Okay, well, I'm just going to write this in. So this would be negative root 3 over 2 is the ratio, and this is negative half. So to find the x value, the cosine of 60 is x over root 3 over 2, or excuse me, x over our radius. Adjacent over 6 root 3. So this is 6 root 3 times the cosine of 60 equals x. Well, I know that that's negative half. So this is negative 3 root 3 equals x. And then the y part, well, the sine of 60, y over 6 root 3. So 6 root 3 times the sine of 60 equals y. Well, that's half. So this is 3 root 3, and it was negative. I feel like I did something wrong here. Oh, I put in the wrong value for the sine of 60. That's what it is. So this was negative root 3 over 2 is y. So 6 divided by 2, that's 3 times 3. So that would be negative 9 equals y. So that's, again, our imaginary part, though. So this is negative root 3 over 3. And I really could put that this is our imaginary instead of y. I should put imaginary minus 9i. So let's take a look at another one of those. So our second one we're going to look at. Let's say we have 4 root 2 times the cosine of 5 pi over 4 plus I the sine of 5 pi over 4. So again, our angle measurement is 5 pi over 4. So I know that's 45. That's our imaginary and our x. And this is 4 root 2. Well, this is negative root 2 over 2, and again, negative root 2 over 2. So the real part. So our real part is the cosine of 45, x over 4 root 2. So 4 root 2, and we said that was negative root 2 over 2 in that quadrant. So 2 times 2 is negative 4. So that's our real part. And the imaginary, so our sine of 45, I over 4 root 2. So 4 root 2 times negative root 2 over 2 equals our imaginary. 4 divided by 2 is 2. So that's, again, negative 4 is our I. So it would be negative 4 minus 4i. And then the last thing we're going to fit on here is if we are going to go from rectangular to polar. And let's say we have negative 6 plus 2 root 3i. So again, I was going to, if we were to graph this here, negative 6 is our real part, 2 root 3. And now we just need to do, again, like yesterday, the Pythagorean theorem. R squared equals 2 root 3 squared plus negative 6 squared. So 4 times 3, so that's 12 plus 36. So r squared equals 48. So r equals the square root of 48. And then we do the tan inverse. So the inverse tan of opposite over adjacent. Well, 2 over negative 6, so that reduces down to the inverse of, let's see, that's a 3, so square root of 3 over negative 3. So again, I have to figure out what that angle is. And I don't know if it's 30, 60, 90. So if it was 60, because it's a unit circle, that would be root 3 over 2 over half. Well, that's just root 3. So it's not a 60 degree. Well, what if I switch this? And if it was, so this would make it a 30 degree reference. So half over root 3 over 2, 1 over root 3. And if we rationalize, okay, so I know that this is 30, but in this quadrant, that's 150. So 5 times 30 is 5 pi over 6. So now just to write it in the complex form. So square root of 48 times the cosine of 5 pi over 6 plus I, the sine of 5 pi over 6.